Hi guys, it's Miss Aguilar once again, and we're doing part 7 of our final review packet. We're starting off with number 15, and the question reads, Sailor, Isabel, and Cassie decide to take a serious hike if one of them has a mass of 51.7 kilograms. And here we have our first value, right? That's our mass. And ascends a 43.2 meter high hill. Here we have height. At a constant speed of 1.20 meters per second. That's our velocity. And it takes 384 seconds to come down the hill. Then determine the following. That was our time. Okay, so it asks for 4 different things. And the first one is the kinetic energy change, the gravitational potential energy change, the work done, and then the power delivered. So the first 2 parts of this problem are asking for the change in the kinetic energy and the change in the gravitational potential energy. Now, in order to figure out what the kinetic energy change of the hiker is, we first have to determine the actual gravitational potential energy and the kinetic energy change, or the kinetic energy, and then subtract the 2. Because your gravitational potential energy is your starting energy. But as the hiker descends down the hill, a lot of that energy is being dispersed into a heat or friction or all the other types of dispersed energy that we didn't really cover and just grouped them all into one category of dispersed energy. Okay, so these values of energy are going to be different, but for kinetic energy, it's not going to be exactly like gravitational potential energy because we're not considering the dispersed energy in that sum. Okay, I hope that makes sense. Okay, so let's first solve for gravitational potential energy. And remember, the equation is mass times gravity times height. And also one other thing to really remember about energy is that it's a scalar quantity. Even though you're using vector quantities to calculate the energy, and it's a scalar, you just pretty much calculate absolute value. You ignore the directional terms like negatives and positives. So you're going to see here that I'm not going to put a negative 9.8 because it's just best to keep them all positive or all negative, but you know. All right, and then we have height, 43.2 meters. That's only supposed to be one little decimal there. All right, so if I was to, or I already did, I calculated this, and I have a value of 21,800, well, it's actually 21,887.7 joules, but I'm just going to round to 21,888 joules. Remember, on the final, you guys aren't going to really have to worry too much on rounding because there will only be 4 possible choices. And I would never make one choice 21,888 and then make another choice 21,887.7 because those are so close together. I mean, I only want one correct answer, and there will always only be one correct answer for your multiple choice problems. All right, so there's our gravitational potential energy. Kinetic energy is 1/2 mass times velocity squared. And so we have 0.5. I've just taken this fraction and turned it into decimal. A mass of 51.7. Again, I'm sorry, I'm leaving out the units just because I don't have enough space and I write really big. And then we have our speed or our velocity, and we're squaring that. I've already done the work, and the total I come up with is 37.2 joules. So you can tell right off the bat that your kinetic energy is a lot less than our gravitational potential energy. And you can account, if you don't account for any of the dispersed energy, that's your value. But if you were to add dispersed energy into it, it would equal 21,888. So it's asking us to figure out what the kinetic energy change is. So if we take the 2 and we subtract, right, we end up with a total of 21,850, I'm sorry. Whoops. 21,850, 50? let's go with 51. It's just rounded. And it's actually a negative value because you're going to put this value first and then that value second. Actually, it can't be a negative value. Strike that. That's the change. Now, that should take you on to the next problem and tell you that, you know what? The change is going to be the exact same thing. 21,850. Well, I said 51, huh? The only reason why I'm saying 51 is because I did the math and I got 21,850.5. So I'm just rounding it to 51. Again, we got this value because we subtracted the 2. All right, now here we have a work problem, work done upon the hiker. So work is equal to force times distance. And remember, you can also write that force as mass times gravity, well, acceleration due to gravity, and then multiply it by the distance or displacement. Another scalar quantity, so we really are going to ignore all of the negatives. So we have a mass of 51.7. We're going to multiply it by 9.8 and then multiply it by how far down they descended, or the displacement, and that was 43.2 meters. Oh, look at that, I added a unit. I might as well do it the rest of them. Okay, so if you did all the work here, you added them all up. I didn't add them up ahead of time. Sorry. Let me just do that. 51.7 times 9.8 times 43.2. And I get a total of, well, this is funny, 21,888 joules. What? How is that the exact same thing? Well, think about it, you guys. Isn't this right here the same thing as gravitational potential energy, except the D is an H? Is exactly the same thing. That's why work and energy not only use the same units, but also use the same variables for solving for either of them. Just something to keep in mind. All right, the last one is to calculate the power delivered by the hiker. So what is power? Power is equal to work divided by time. We have that time value, so we're going to use it now. Sorry. I was just trying to pull this down, and I'm looking right here. This is our work value. And so we have 21,888 joules, and we're going to divide that by the time it takes, and that's 384 seconds. The value you should get is, let's see, 21,888 divided by 384 seconds. The power output was 57. And what are the units? Watts. So that's your answer. This is a really drawn out problem. I probably can safely say that if you do have a problem like this, it won't be asking for A, B, C, and D. It would probably just be A and B at the most. So don't expect to have to go through and then, calculate both gravitational potential energy and work. It will probably either be just work and power or gravitational potential energy and kinetic energy, but not all four. So I can actually guarantee that. So don't stress too much about that. Well, don't stress about it at all. You guys are going to be doing fine. I know you will. Okay, so how are gravitational, now this is electrostatic. So we just finished up with the, with the work, power, energy part, and now we're moving into electrostatics. So I know that I skipped over waves. That's just because we already have a study guide on waves, and it is also videos I did for the study guide, and it's under Unit 8 study guide. And if you guys look in the same place of my YouTube, you'll see those videos. Just look for Unit 8 study guide or study review or review videos. And I think there's 2 or 3 videos for that as well. So I'm actually going to stop here. That was just one problem, I know, but I'm going to stop here, and then I'm going to make a whole brand new video just for electrostatics. All right, guys.